So a real-world example, write an exponential function. So a science question. Khadija starts an experiment with 7,500 bacteria cells. After 4 hours, there are 23,000 cells. Write an exponential function that could be used to model the number of bacteria after X hours, if the number of bacteria changes at the same rate. So let's highlight the key information. So at the start, this was 7,500, so the initial amount, the amount at the start, so this is going to be A. This is equal to 7,500. So after 4 hours, so our time, and we're asked after X hours, so we're using X. This is going to be our time, and this will be 4 hours. And also we have 23,000 cells. So this is going to be Y, which is our final amount, the amount at the end. So this is 23,000 cells. So from previous questions, we used Y is equal to A, and we had 1 plus R to the T. So in this case, we're going to be looking at Y is equal to A. We need to find this rate, but in our question, so we're going to be using the letter B. So this is going to be AB, where B is the 1 plus the rate. So B, this is our 1 plus our rate in decimal, and we don't know this value. And this is going to be to the power, so our B value is to the power of the number of years, and in our case it is X. So we're going to substitute in the values. So I'm just going to delete this one because we're not using this. So we're looking at this form. So the final amount, 23,000. So let's just move this up. 23,000 equals A. The initial amount, 7,500, multiplied by B, which we don't know. And this is to the power of X, which we know is 4. So we're going to divide both sides by 7,500. So this will simplify, and we'll have B to the 4 is equal to, so we've got 3.06666, so I'm going to just round that. So 3.067, and we need to take the fourth root. So B will be the fourth root of our answer. So I'm not rounding that in my calculator. So that will be approximately 1.323. So this is going to be our rate here. Our rate, 1.323. So now I can use this information and put it into our equation. So an equation to model this experiment. So Y is equal to, and we need to use, so we've got the initial amount, which is 7,500. This is multiplied by our rate, which is 1.323, and this is to the power of X. So part B of our question. So it says, how many bacteria cells can be expected in the sample after 12 hours. So we need to substitute in the values to our equation. So y is equal to 7,500. We have our rate. So 12 hours, this is our value for x. So y is approximately, so if we calculate this in our calculator, 215,665, so 215,665 bacteria after 12 hours.